In lesson 2.7, we're graphing circular functions, which means we are graphing in radian measure. So this is the same kind of graphing that we did with trigonometric functions, only here we're just going to be in radians. A is amplitude. B, the number in front of your parentheses, is going to be the number of cycles within 2 pi radians. And this is how you find your period. C, the number being added in front, is your vertical displacement. And D, the number being subtracted from x, is your phase displacement. The period for the sinusoid will be 2 pi divided by whatever the b number is. If we see x in the equation, we are graphing in radians. If we see theta in the equation, we are graphing in degrees. So these are the same things we talked about before, only we're adding this x to the problem. In example 1, we are sketching this graph, and you can either go right into making a graph, or I am going to make a table to start this out. So we're going to start with our radian measures for the x. We get these from the unit circle. That would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now we're going to take those x values, we're starting here and going this way, and we're going to do the opposite of pi over 10, which would be 10 over pi. And we are multiplying everything by 10 over pi. So that would be 10 pi over 2 pi, and that reduces to 5. That would be 10 pi over pi, which reduces to 10. This would be 30 pi over 2 pi, which reduces to 15. And this would be 20 pi over pi, which reduces to 20. Next, we're going to add 2 to all of those. We're going to add 2. So that would be 2, 7, 12, 17, and 22. And those are the x values that you're going to put on your x-axis. Let's just go ahead and do that. So that'll be one full cycle for the sinusoid. Now we're going to go back to cosine and go to the left. So we're going to start with our cosine values. 1, 0, negative 1, 0, 1. Then we're going to multiply those by 4. Then we're going to subtract 3 from all those. These are the y values we're going to graph. Which means we have a sinusoidal axis at negative 3, because that is the middle y value. And we see that at 2, we are at positive 1, which is why it's a cosine wave. It's starting at a high point. 7's at negative 3, 12's at negative 7, 17's at negative 3, 22 is at 1. And that is your sinusoid. Now let's just list our important information. So we've got a vertical displacement of negative 3, which we can see first in the equation, or you can find it here in the graph. It is your sinusoidal axis. We have a phase displacement of positive 2, which we can find here in the equation, or it's the first high point in your graph, or your starting x value. We've got an amplitude of 4, which we can find here in the equation, or you can count from negative 3 to positive 1. It's the distance from the high point to the sinusoidal axis. And then you've got a period of 22, which you can, no, not 22, 20, which you can find right here in your table. You also could find it on the graph by doing your last point minus your first point, or high point minus the high point. So 22 minus 2 is 20. Or you can take it from your equation up here and do 2 pi divided by pi over 10, which you would have to multiply by the reciprocal, and that is how you're getting 20 for your period. equation. If we look at our graph, we've got a domain of negative infinity to infinity, because it is a smooth curve going all the way to the right with an arrow, all the way to the left with an arrow. We've got a range of a lowest y value of -7 and a highest y value of +1, and those are in brackets. Okay, let's graph example 2. Let's start by making a table. So I'm going to start with my x values, and we're going to go this way. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now we're going to do the opposite of the 1/4, which would be multiplied by 4 over 1, which will be 0, 4 pi over 2, which is going to reduce to 2 pi. Then we've got 4 times pi. Then we'll have 12 pi over 2, which reduces to 6 pi. Then we have 8 pi. Then next we have a plus pi in the equation, which means we are going to subtract pi from all of those. So that'll be negative pi, 1 pi, 3 pi, 5 pi, 7 pi. Those are the x values we're going to graph. So we start at negative pi, then positive pi, 3 pi, 5 pi, and 7 pi. Then we have our cosine values, which are 1, 0, -1, 0, and 1. And we're going this way in the equation. We're going to multiply by 3 next. And we're going to add 5 to all of those. So that'll be 8, 5, 2, 5, and 8. Those are the y values we're going to graph. So at negative pi, we're at 8. Negative pi, we're at 8 because it's the high point, and that is what cosine is. There's a sinusoidal axis at 5. Yeah, at 5 because it's the middle y value. Pi is at 5, 3 pi is at 2, 5 pi is at 5, and 7 pi is at 8. So that is what your cosine wave looks like. When we look through the equation and the graph, we've got a vertical displacement of 5, which is the first number. It's also your dotted line. We've got a phase displacement of negative pi. It's the first x value. It's also there in your equation. We've got an amplitude of 3. It's the number in front of cosine. It's also the distance from 8 to 5 or from 5 to 2. We've got a period of 8 pi, which you can see in your second column, or you can take your final x value and subtract your starting x value, or you can take 2 pi times the reciprocal of your b, which is your 8 pi there. This has a domain of negative infinity to infinity. This has a range of 2 to 8.